So to discuss two sample test of hypothesis for mean for the independent sample, we'll compare the mean weekly salary of two population, that is school teachers and nurse. So you can say the two groups also, one is school teachers and another is nurse. Although we have two groups, mean school teacher and nurses, but in terms of variable we have two variable here. If we collect data from, we'll ask each one about their profession and their salary. So our variable is basically profession and salary. So in profession we have two categories, that is school teachers and nurses, and in salary we have some disease. So first of all, we have to input our data in SPSS to do the analysis. So let's see how we can do that. While we'll input data in SPSS, we have two variables. One is professions and another is data. So in the SPSS, we usually, so this is our SPSS window. So in SPSS, we usually have two options. One is data view, another is variable view. In variable view, we usually create our variables, and in data view, we input our data. So first of all, we'll create variable in variable view. That is the first step to input data in space. You have to create variable first by using the variable view. So in variable view, first you see the name. So we have two variables. One is profession and another is salary. So you see, you wrote the name of these two variables. All of the others options are automatically filled. So if you want to know more about or how to input data in SPSS, you check my another video that is titled how to input data in SPSS. So here in the variable professions, the type is numeric, although our variable is not numeric, our variable is categorical. So for categorical variable we choose string, but for this particular variables profession we are choosing numeric, because we have here we have two category basically. One is nurse, school teachers, and another is nurse. We'll convert these two categories into numbers, so that's why we keep it as numeric variable. And salaries automatically will get some numbers. We have some numbers here, so this is automatically numeric variable, so we just keep it as numeric. And another thing you need to change here is values, because since we are converting our variable profession to the numeric, so we'll convert it as, suppose one is school teacher and two is nurse. So so this is our two groups. You just add this group here and press OK, then your values are created. Now your categorical variable profession is converted to the numeric values. I mean teachers and school teachers and nurses converted to the numeric values. And so here our variable profession is nominal, because profession we have some categories, school teachers and nurses, since these are some just name or categories, so this is nominal. And our salary is scale, okay, as it is, as we have some numbers as our data. So here we have some categories, that's why it is nominal, and here we have some number, that's why it is scale measures. So okay, next you have to go to the data view. Okay, so up from the variable view we just have to go to the data view. Two variables, one is profession, another is salary. So if you want to input our data, here we have school teachers and nurses in profession, and in salary we have this value. So our first data is suppose school teachers. So we have 1 and C. Automatically you have we have school teachers here, and for the first school teacher salary is 845, and for the second school teacher salary is 826. For the third school teacher salary is 827. Okay, so similarly we can just input here. We have nurse and salary of the nurse. So our first nurse salary is 841, so nurse and salary is 841, and second salary is 890. So we can just input our data like that. So in profession we have school teachers and nurses, and in salary we have their salary. So this is how we basically input our data from this example or from any other example. Okay, so now we have two variables, profession and salary. To perform two sample test of hypothesis for mean and for the independent sample, you have to just choose the analyze option. Okay, here we have analyze option. Then in analyze option we have compare means. Okay, in compare means, since our samples are independent, we will choose independent sample t-test. So in independent sample t-test, so we'll have this box. You see the box. So here we have test variable and grouping variable. So our test variable is basically salary, as we are testing or comparing the salary of the two groups. So we'll select salary here, and our grouping variable is profession, as we are we have two groups there, school teachers and nurses, and we want to compare these groups. So that's a profession will be here. And in defined groups we are just defining the two groups we want to compare. One is school teachers, group 1, and 2 is profession, as we have already coded school teachers as 1 and nurses as 2. So we will just write this here accordingly, then just select continue, and here you have options. Here you have 95% confidence interval. If you want to change it, you can change it, but 95% is the standard one, so you'll just choose that, continue. And after you are okay with the test variable, salary, grouping variable, professions, and define groups, you just press OK. So if we press OK, then we'll get this output in output. Seen in your output. So we have this output as our SPSS result. So here we have group statistics and then sample test. So in group statistics you just have some basic information of the two groups, school teacher and nurse. In school teacher we have mean and standard deviation, also standard error of the mean. In nurses we have mean, standard deviation, and standard error of the mean. But we'll make decision about the mean salary of the two groups by using this table. This is called the independent sample test table. So here we have basically result of the hypothesis testing. Okay, here we have to compare the mean salary of school teachers and nurses. How you can compare the mean salary of these two groups, we'll just see that. So this is our SPSS result. Here we have the result for the variance test, and here we have result for the equality of means test. So this is our main result where we want to compare the mean salary, and we use variance test because for this test we have two options. One is equal variance assumed and another is not equal variance assumed. So we have to work between one of them. So that's why we do this variance test. So how we can decide about these two tests and how we can make decision about the variance test, we'll just see that here. So here in variance test we basically compare the variance, population variance of the salary of school teachers and population variance of the salary of nurses. Here null hypothesis is sigma 1 square equal to sigma square, that is equal variance assumed, and alternative hypothesis is sigma 1 square is not equal to sigma 2 square, that is equal variance not assumed. So since you have to work between one of them, so that's why you have to make decision that which one is true. So to make this decision, we usually use this significant value. Okay, so the significant value is basically p-value. You see the significant value here. Okay, so this is basically p-value, and we have to compare. So see, this is 0.32, and we compare this p-value with the level of significance alpha. Suppose alpha equal to 0.01, so in that case our p-value is 0.322. So we make decision about the hypothesis by using p-value and alpha. If p-value is greater than or equal alpha, then we usually say that null hypothesis, that means H naught is true. If p-value is less than alpha, then we say that H1 is true. So since we have since p-value here, p-value 0.322 is greater than alpha equal to 0.01, so we cannot reject the H naught. That means so you have to assume that H naught is true, so sigma 1 is square equal to sigma 2 is square. So we'll basically choose this option, equal variance. Okay, so this option is crossed. So now in mean test, you see also the hypothesis. So in mean test, we basically comparing the mean population mean of the mean salary of the two groups. Here mu1 is the population mean salary of school teachers, and mu2 is the population mean salary of nurses. So why our H1 alternative hypothesis is like mu1 is less than mu2, that is school teachers is less than nurse? Because we select our H1, that is alternative hypothesis, from the question as here we have the question, is it reasonable to conclude that mean weekly salary of nurses is higher? That means salary of nurses higher. We have to test that whether nurses salary is higher than the school teacher. So usually the question that is asked to test is we keep that in the alternative hypothesis. So that's why we wrote here mu1 is less than mu2, that means nurses salary are higher than the school teacher's salary, and H naught, our null hypothesis, usually opposite of that. So similarly, we'll compare this hypothesis, or we'll make decision about this hypothesis by using the p-value. So suppose our level of significance here is 0.01, and since we'll assume that our variances are equal, so we'll consider this p-value to take decision about the hypothesis. So this p-value is for two-tailed test. You see here it is written the two-tailed test. So for two-tailed test, our p-value is 0.489. We had this from this result, 0.489. But our test is one-tailed. If it is less than or greater than, it is always one-tailed test. In two-tailed test, our hypothesis is usually equal and not equal. To find the p-value for one-tailed test, we have to divide the p-value for the two-tailed test by 2. Then we'll get the p-value for one-tailed test. And now we'll compare this p-value with alpha, that is level of significance. Since our p-value is greater than alpha, so H0 is not rejected. That means you can say that mu1 is greater than or equal to mu2. So you can say that we can't make a conclusion, or it is not reasonable to make conclusion that mean salary of nurses is higher, since our alternative hypothesis is not true. So this is how we usually make decision about two sample test of hypothesis for mean when our samples are independent and when sigma 1 and sigma 2 unknown. But if you have any questions regarding the topic or any other topic, you can just make comments. If you have suggestions, you can free to give that. I'll try to improve myself in that sector. So thank you.